welcome to Ladyada.
Hey everybody, like floppy dress here. Welcome to the desk of Ladyada, where floppies unite. Welcome to the desk. Okay, so we've been doing a lot of hacking with displays. But first up, is there any news or updates, Mr.
Bunch of shows this week. Tomorrow, if you're interested in open source hardware, I have an article that should be going live. And then lots and lots and lots of content this week. We're on a hardware tear, as they say.
Yeah.
So that's going on.
Yeah.
But besides that, this is all about your desk and what's on it, lady.
Okay.
What's happening?
All right. So some weeks like I jump between different topics. This week is a little bit of a continuation of last week. So one of the things we talked about last week is I got all these cool, weird displays, like a bar display. It looks like it could be like cool glasses or anonymity screening. There you go, a little mini bar display. Square displays with cap touch. Enormous round displays with eyeballs on them. More bar displays, some with touch, some without. A little round display here. Rectangular displays. And we talked about the difference between these displays. These rectangular displays, they do not require initialization. You can just send 800 by 480 RGB data with VSync and HSync pulses, and they will just magically display the right stuff. Whereas these funky displays, the round, the square, the bar, tend to use a driver chip called the ST7701S. I'm just familiar with it. And this display does require you to initialize it, and there's separate RGB pins that do it. And so I think last week we showed how we were using the ESP32-S3 Eval board. This did have a display on it, which I've removed. I had this square display it comes with, and this is like on DigiKey, like 50, 60 bucks. And it's a really good deal because you get the display, the cap touch, the module, USB and native and USB debug. And I use this just to get things up and running, like the pinout connection for all of these funky displays, the square, round, and bar. Thankfully, the pinout is the same. So what I could do is just remove this overlay part. And on the back, there's a little FPC connector. You pop it open, you put the new screen in, you put it back. And then there was a Arduino library called RGB display that supported this particular eval board. And the reason it's not just the pinout you need, but this eval board also uses a GPIO expander to toggle the SPI pins. And so I was like, oh, like that's kind of annoying because it's much more convenient if you can just use the native SPI peripheral on an ESP32-S3 to do that configuration, because you do have to do it once, configure it, and then you can start blasting the data. But the configuration does have to happen every time you start up. So I did design a PCB. Just go to the computer. I'll show. Okay, so this is the PCB I designed. Let's just do basic top. And it's got your ESP32-S3 module. One moment, let me turn on TDocu. I should have it do that by default, but I keep forgetting. You have your ESP32-S3 module, and you can tell I kind of took the matrix portal S3 and I kind of pulled out the matrix part and put in the TFT part. So this module has 16 or 8 megabytes of flash and 8 megabytes of octal PSRAM. And most ESP32-S2 and S3 modules do not have octal PSRAM. This is a new thing. And octal, as you can imagine from these, there's normal SPI, there's quad SPI, QSPI, and OSPI, octal. Octal uses 8 pins to do parallel data transfer back and forth. So you're going to get twice as much data as quad, because octal 2 times quad 4. We'll talk about that in a bit. And you do need that high speed, because normally when you're thinking of RAM on a microcontroller, the RAM is on chip. It's bonded directly into the data bus, and so you get like one instruction or maybe 2 instruction access to RAM. It's like instantaneous. With PSRAM, it's off chip. It's a separate chip off of the main microcontroller, and there's those pins that connect. You have to get the data off, and it's an order of magnitude or more slower. And one of the things when you study computer architecture is they're like, the CPU cache is the fastest, the registers and the CPU cache are the fastest, and then the RAM is fast, and then the offboard RAM is slower, and then by the time you're getting to disk, it's like decades in terms of microcontroller or microcomputer time. The more separated it is, the more storage you have and the cheaper, but it takes more time. And when you're using this to display data, remember, you have to blast those pixels out continuously. So you need that octal PSRAM to get that fast access, so you can like blast out those pixels at a 25 megahertz clock rate. Yes, there's caching, but you still have to like write a whole line and still have time to go and get that data off of the PSRAM. So the octal is essential. I think you can do small displays with non-octal, but once you get to the 480, 720, you'll need it. Power supply, backlight driver over here, 2 buttons, NeoPixel, STEM QT, I2C. Another nice thing about these displays is they often have built-in capacitive touch controllers, and so I have I2C connected over here to you can see the test the touch panel, IRQ, SDA, SCL, and reset. And then you got the 5 bits of red, 6 bits of green, 5 bits of blue, and then the control lines, DE, VSync, HSync, and then this is pixel clock. It's not labeled. And then here are those SPI pins, SCK, MOSI, and CS. It's 3-wire SPI. You only write and don't read data back. It's only for that initialization, and then you can reuse the pins for other stuff. So I got the prototype together, and we'll show it on the overhead real fast before I explain. So this is the display. This is the physical version of it, and it didn't work because I made a mistake, and apparently, like a lot of people made this mistake. So hopefully, if you watch this video and you're doing stuff with the ESP32-S3, especially the new, the octal version. So when you want to use octal, I was actually kind of wondering, like, oh, like where those extra like 4 pins come for the octal PSRAM, and it's a little confusing because it'll recognize it as octal PSRAM, and it'll work even if you have stuff connected to those pins. But then later, if you use them and you access the PSRAM, like, it can get confusing, because it turns out that these pins over here, these 3, which is 35, 36, and 37, IO, those are used for the octal PSRAM and cannot be used by external components. And I found out that real fast. In fact, if you try to initialize your TFT display using those pins, it'll hard fault, and you'll be like, why is it hard faulting? And then you'll like dig around and like remove pin. You'll be like, well, maybe there's something with the pin. Some of them have to be in a certain order. And then you'll be like, what's special about these pins? And then you'll realize that everyone else bumped into like there's so many posts and issues on like every project I saw that was like, oh, by the way, you can't use these 3 pins if you're using the octal PSRAM. So, but you can use them if you're using the RAM in quad mode, and I believe it does work in quad mode, although I had to do a little bit more analysis to figure out what's going on here. So what I did is, what was funny is the display would work if I didn't use those pins for the TFT peripheral, but what would happen is the display would have all the like these dots everywhere from the octal PSRAM access data coming through and then displaying onto the TFT, which was very cute, but it was a little annoying. So, because I wanted to see good graphics, so I just kept those 3 traces, and then I did a trick where I just shorted the. It was like 1 blue line and 2 green lines. I just shorted them to the next bit over. So you're not going to get all the colors. You're not going to get full 5 or 6 bit. You'll get 4 bits. But at least like it'll display, it'll just like look a little rough. It'll look, a little more, not pixelated, but like chunkier, because you're not going to get the whole gradient of color, but it's okay. Just to get this going. And then otherwise it works pretty well. So let's look at the animation here. So I've got it hooked up to the 2.1-inch display. Let's see if I can get it. So, this is actually, because this was using the plain GPIO for the SPI configuration, I was able to use an easier to use library called Arduino_GFX, which is actually based heavily on Adafruit GFX, but they did a really good job with it. And I'm like, totally, like, I licensed at MIT so other people could do a better job, because the goal of Adafruit GFX in our libraries is to get people going. It's not going to be the fastest or like the best graphics library. Better to to get it working. And then this person really optimized it and also added graphic support for parallel displays. And they wrote a MJPEG player. So this, what I did here is I had all these free pins. This is the SPI, S-Clock, Mosi, MISO, and then 2 analog pins. And these were used for configuring that TFT display. But again, once you're done with the configuration, the pins are free. And I wired up a SD card. So let's go to the computer and I'll show the example code I wrote. Yeah, so I just, it's using JPEG decode from Bitbank, who's also written some code optimization for us. Did a really great job with this MJPEG decoder. And I've never actually heard of MJPEG, but MJPEG is movie JPEG, and it's often used for security cameras, which is interesting because MJPEG is exactly what you think it is, which is just JPEGs concatenated one after the other. There is like nothing special about this this format. There's no like encapsulation. There's no high level encoding. I have a few videos, and I'll just show the Bill Nye. It starts with it's just JPEG, and then if you search for this, hex values, all. Hold on, FFD8, search all. You'll see, this is just a hex analysis. These are all the frames, and the frames are just like, da, 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 da. It starts with FFD8 and it ends with FFD9. And so you see this is one frame, another frame, and then they just go through the file, concatenated. And when you get to the end of the file, you're like, movie's done. And that's why it's really great for use in security cameras or like data logging, or like if you wanted to do time lapses, because you just like concatenate the JPEG one after the other. And then when you're done, you don't have to like finish the file or put the header to tell it, oh, here's the frame rate. But it is a very basic format. Obviously it doesn't have audio and it doesn't do like time coding. And you also don't get to share the data between the JPEGs. So it's not as small as it would be if it was using like H.264 encoding. But the good news is that it's very, very fast. I timed decoding the JPEGs on this 480 by 480 display, and it's like 150 milliseconds. It's actually like, okay, you can get like 10 frames a second pretty much with it. Not beautiful quality, but like it's animation, right? It's much better. And a lot of the time is taken for this MJPEG decoding. Hold on, let me reset this because it went, oh, you know what? I think I also kind of messed with it a little bit. And it came loose. Let me restart this and I can show you the timing. And this is each frame. It's like drawing a dot for each frame. And I think it shows you, in the end, the amount of time is mostly spent reading. Here you go. So total frames, 96, 10 seconds playing, 9 frames per second. A significant amount of, like 10% of the time is reading the file. And then, the majority of the time, 60% is decoding it. But you could actually speed this up a little bit by using, again, quad SDIO, not SPI or 1-bit SDIO on the SD card. And you can also improve the access time by having it on the built-in flash memory. But of course, this flash memory inside the ESP32-S3, but of course that's a limited space. Whereas what's nice about SD card is pop it out, drag some more MJPEGs. So if you go to the overhead, you can see you wanted me to, Mr. Ladyada wanted me to add a Stargate animation.
Yeah, it's a pocket Stargate.
Stargate, this cool dial.
That's a cool dial. I wanted it because I thought it would be neat to show maybe combination lock or just volume, like when you turn the volume on something.
Yeah, this is a
Butterfly, I don't know about that one.
This is from Pixels. It's open. It's a free video.
I had nothing to do with that one.
Well, okay, so how much time do I have left?
You got plenty of time.
Okay.
Do you have other animations that I sent you, or is those?
They're all going to play in order, but this
How long does the butterfly take to play?
about 8.5 hours.
Really?
I'm just kidding. It's like 20 seconds.
Oh, okay.
Give it
I
a
was like, is this a director's cut?
Well, I wanted to see how long. I wanted to see, like, does it matter how long
Yeah,
it
I
is?
mean it's nice and everything. Remember when we went to the Museum of Natural History and we saw the butterflies?
They have a cool butterfly.
We brought our little kiddo and she looked at the butterflies, and it was cute.
It was very cute.
Okay, it looks like it's playing the same.
Oh, you know, I think it's because it's looping.
Yeah.
Oh, sorry.
All right.
Oh, you know what? I have two.
You have two butterflies?
I think I dragged it over. Oh yeah, I did. I dragged it over twice
Really? I can fill up more airtime
with butterflies.
with
Okay.
butterflies.
But what other videos did you want to show?
Okay. Well, the other videos that I sent you
Which
were
one?
the laundry machine one.
You showed that one.
Where? You showed it?
That was at the beginning.
Oh.
Yeah.
Oh, you know, I was switching screens or something
Yeah.
like that. Okay.
And then there's the Bill Nye head. We saw that.
Yeah. Um,
And the knob.
yeah, the knob.
And the Stargate.
So
That's all I had.
Yeah. Okay. So the laundry one, by the way.
Yeah.
The laundry one, the reason why I like that one is because I wanted to. There it is. Yeah, maybe you can tilt it. So the idea with this is you use Adafruit IO or Whippersnapper, and it'll show. Yeah, it'll show when your laundry's actually being tossed, and when it's done, it'll say go change your laundry.
Yeah.
Instead of it just being like not something that you really like associate with laundry, it would actually be laundry.
Yeah.
So I thought that would be cool. And the Stargate, there was an episode where they made a small Stargate. There's other ones that we have that I'm gonna make after we get off air.
Yeah.
But I thought this was a good start. The Pocket Stargate, so that could just go on your desk just like that.
Yeah.
I thought that'd be really cool.
Yeah, and then let me show back in the computer. So I have to go to pop computer real fast.
Okay.
I'll show people how you create MJPEGs. You use FFmpeg, so you can see here the command I did. So you get an MP4, and then you do this like you resize it, and you convert it to MJPEG. You pick quality 9. The higher the quality, I think the longer it takes to decode. So it's a trade off of like decoding length. And then you crop it, and then let's say one thing: the original command line that was in the tutorial for this library had a argument that actually turns out it was this library. This is what I came up with, but hold on. Libraries. I'm going to show it because it's totally, I was like, I spent like, not like that long, like an hour on it. It was image viewer, MPEG. This command here, set PTS, it changes this like how fast or slow it is. And there's like either a bug or something with, FFmpeg, and it would like freeze the frame for like 10 seconds. And I was like, the decoder crashed. It actually was like literally the MJPEG didn't work, but it's so hard to view an MJPEG on a computer. Like I actually had to find like this like car video viewer. It got a little funky, but do check your video, download an MJPEG viewer to view the video before you put it in to make sure that the formatting is correct. Okay, so that's the viewer, and then we have more screens. And so the last thing I wanted to show, because I thought it was cool, we'll do a video, like a 10 p.m. video for tomorrow maybe or something, where I show it in more detail, is one of the things that is really annoying about these displays is you have to do the init code. And the init code, every library has a different format for the init code, and they're not small. Like this is the init code for the 3.4 inch, and you see it's like write a command, then write 5 bytes, and then you have to sometimes put a little like delay function to, because it's like leave sleep, and then you do a delay, and you have to have it exactly perfect. If you make 1 byte of a mistake, it's not going to work. Even some of them are gamma, and you can be a little bit finicky, but some are like these voltages or like the offsets, and you really have to get it all right. You have to get it exactly correctly, and there's no documentation whatsoever on what they do. So you just have to like copy and paste it by hand. And like I said, every library is different. So this RGB library uses this format, and then I'll show the other library I used. What was it called? It was called, oh my God, I forgot the name of it. Yeah, display panel. This one uses a different format. It's like the same data, but it wants it to be byte and then a bracket with like the data and then the number of bytes afterwards. So you can see here, like this, the commands are similar. So this one is like write command OFF and then writes 5 bytes, 7100013. And this one, it just wants it in a different format because it says however the library decides it wants to send the data. And so like a significant amount of your time is spent just like getting it into this right format. And it's like very, like you have to have all your faculties. So like doing it at 1 in the morning after the baby's asleep is kind of challenging. And then Mr. Ladyada was like, well, why don't you try ChatGPT-4? And I was like, ChatGPT-4 can't do this stuff.
Yeah. So let me just, you know,
Why don't you tell?
so we have, we have a good,
Because this is how it comes.
yeah, we have a good community and we have awesome people. And there's a lot of tools that are out there like autocorrect or auto router or new tools like ChatGPT and code analysis. So we have a disclosure policy. Anytime we use any of these, we'll disclose it. And to be really, really specific, most of the code out there for microcontrollers, it's ours.
It's ours
So,
anyway.
so when you see ChatGPT or any of these tools generating code, you'll see Adafruit in it a lot.
Okay.
That's fine. But here's the last piece. There's a lot of people that turn this into like a polarizing thing. You should never use AI for anything. So this is our use of it, which is it's our stuff. We're using it to look at our stuff and we're having it help us with our stuff. And we disclose it when we do, and then we link to the model that it was using that specific date. So that says ChatGPT August 3rd version. So I have an article coming out where we did some data analysis on the OSHWA API JSON file with all the open source hardware certifications. I disclose that I use this tool. It's the data from OSHWA, which is freely available. But the problem is some rando is going to say, you use ChatGPT to write that whole article, do everything. No, look at the disclosure. So that's my rant. Back to you.
Okay. So there's a new capability called code interpreter beta. You do have to have like the paid. It's not expensive. I think this whole thing is going to be like 50 cents. It was just totally worth it to me. But you want to be the code interpreter, and then you press the plus button, and then I'm going to upload the file that I got from the factory. And this is how the file looks. It's just like this extremely raw, like write byte, write data, and at the top it has this, and say, I want to convert this list of C statements. Please analyze it. And I did do this before, so of course I want to make sure, but we'll see. Like I'm gonna have slightly different commands because I'm gonna skip ahead because I was kind of having it like do other analysis stuff. Okay. I would like, whoa, I would like to type. I would like to reformat this data. A little chatty. Ooh. Okay. Let's start with, I want to combine it into one line. Please combine the SPI write com and subsequent SPI write data lines so that it is one function call with the command byte first and the subsequent data bytes following as arguments. Okay. I will say one thing that's interesting about ChatGPT is like you have to be very specific about what you want. So it's not like if you don't know what you want, I think it could be challenging. You might have to go back and forth, but like just crafting it so it's like really specific. Like try not to use the word like that, this, whatever. Okay. Save to a file. All right, let's see if it pops out. Okay. Well, let's look. Okay, so here you go. This is like the first step. So what was write command data, 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 write command data, data is now at least like converted into one call that is the data and then the bytes afterwards. I would like to reformat it a different way. Okay, so now let's actually format it to use the format that is required by the Arduino RGB library. Okay. Let's see, how did I say this? Start each command with the string write command 8 CMD, where CMD is the command byte. Then on the next line, have it say write bytes n, where n is the number of data bytes. Finally, on the third line, have the string, have the list of data bytes separated by commas. Okay. This a little bit, it's I'm kind of describing it a little bit differently than I did before. I can also show the what I did earlier. But let's see if it can. I was trying like I'm combining some of the requests at the same time. Okay. Yes. And let's take a look. Okay, so let's look. Statements, and there you go. So now you can see that it's given me it. You know, I should have told it like, oh, I want a comma at the end of each statement, which I can do next. Can you update it so each line has a comma at the end? Which I think, yeah. Okay. Beep, beep, beep. Okay. Let's look now. Ooh, great. So add the commas. And I'm going to do the last thing, which was I wanted it. One of the interesting things about this library is that this is totally valid. You can absolutely just use this. But if it is a single byte command, like if you only have one byte you're writing, you can use this like function called write C8D8. Please replace both the write command and write. Okay, if there is only one byte of data, please replace both the write command and write bytes lines with a new line. Write C8D8 command data, where command is the data, so is the command byte, and data it is the data byte. Yeah, all this could be done with awk and like sed, but I don't remember awk and sed anymore, by the way. I lost that book.
What happens when you click show work? Do you want to show that there?
Yeah, that's a good question. Okay, well, let's look at this. Let's just look to see if it's came out right.
I can't wait to hear that Ladyada has OpenAI regular code.
So this has double commas. I'm just going to tell it, hey, remove the comma. Please remove any double commas. Yeah, it looks like because I told it to add the comma, and
Oh.
it had the extra comma here.
Like,
So I just told it, hey,
I
just
think it like it apologizes. Like, oh, sorry.
well, I'm polite. I say please.
Yeah.
I can't help it.
My opinion is if you got to be polite no matter what.
Yes.
If people believe like, oh, I think I believe in I like science fiction. These things are gonna be sentient one day. Well, you can be polite. Doesn't.
Okay, and that's it. I think this is it. Oh, you know what's interesting? It didn't remove the write command from the original write command. Oh, interesting. Can you remove any write command 8 lines if they are preceded by a write C8? Yeah, I see what happened.
Click show work white sooner.
Huh?
Click show work.
Show work?
Yeah,
Okay.
no, the one that it's on.
Oh, the one that's on?
Yeah, it keeps going.
Okay.
Down there. Keep going. Yeah, show work. There. Look, it's going. Look at it. Look at it go.
Oh, interesting. So it's writing to Python.
Yeah. See, this is why the kids. This is why people say you learn Python.
I will say, you have to check the output. Like, I'm checking it each time and being like, is this correct? Okay, now, yeah, write command, write bytes, write command. Oh, it didn't do it. Interesting. I think I have to start from the beginning, maybe. This is actually so I'll show what I did yesterday. I think I'm like, because I'm like starting to like put a lot of them in order. I mean, I could just remove the extras. It didn't.
This is another thing too. So these tools don't do everything for you.
It doesn't do everything for you.
You got it.
So this one,
you got to work with it.
yeah. This is what I said last time. So this time I would like the command byte to be prepped with the string, write command 8. So it's a little bit more like verbose. And what's interesting is that this time, maybe because I'm kind of doing it the second time and it has that context, it actually told me like, hey, this is what I'm going to do. Is that okay? And then it like proceeded. But this one, I think because I was like a little bit more clear, I was like, yeah, if the number of bytes is 1, replace it on command and the right bytes. This time it told me, hey, I'm going to replace these things with this thing, with this line. And then in the end, it did give me, oh, I just lost it. Hold on, let's see. This is what it gave me in the end. Another thing that's interesting is I told it to reformat the file after like analyzing it. And maybe that's why it kept this delay comment in here. I had a couple delay comments, but it's still way faster than doing by hand. So I'm going to keep experimenting with this because I have a lot of these files I have to parse and I do not want to do it by hand. It is still faster, I think, to have it do at least that first analysis and to like reformat it. And again, the one that the third file it generated was correct. I just was like, oh, I want to like compress it a little bit. That's probably where I went wrong. But yeah, this is cool. Anyways, so that's my experimentation with using AI tools to help me through some of the manual labor of editing files for microcontrollers.
I heard you just go to Dolly and say, make me PCBs, and PCBs pop out, and then you go to Bard and you say, make code for me, and it just makes code.
I'm actually kind of glad that it didn't do a perfect job the second time because it shows you have to check the work. It saves you from like doing things, but you still have to verify the output.
Maybe because I've been a quote journalist for a couple of decades, and there's an editorial process. I look at using these tools like me working with an editor working with me, and it's a collaborative process.
Yeah.
And that's where the maximizing human potential comes out. I don't expect it to do my work. I wouldn't want it to. I like working with tools. I like spell check.
Yeah.
I don't want to spell. Okay, you want to move on the great search? You want to keep talking to this robot?
Oh, I made a mistake. It wasn't preceded. Yeah. Well, let me just try one more thing. Sorry, that last command was incorrect. What? Yes, that's what I meant.
Chili.
Precede and proceed, very annoying.
Oh, little happy robot.
They sound the same, but they're opposite. I wanted it with the function call afterwards. This is the thing. You have to give it the instructions. You have to tell it what you want to tell it. I love how it's all opening up in Emacs. It's like the oldest. It's like the oldest editor chatting with like the latest. Okay. Let's see if I got it right this time. That was my. See, you had like bad data in, bad data out.
We didn't plan this.
Okay. Let's see. Write command, write bytes. Now it's. Is it correct? No, because it actually used the wrong file. Ooh. All right. I should have probably just started over. But some of these are correct, but it looks like this line, write command FF, and then this was correct, but then it still had removed the lines from the preceding step. I should have told it to undo. But I don't think it can understand context of like 2 steps beforehand. This is probably what I would actually just start over and I would like place the commands in, but I would just like not make that
So
mistake.
I've
What do you do when you
so when I was doing some of the Asha stuff, it was remembering the past commands, and I had to basically say like stop, clear, and because it was getting caught up with the current command.
Yeah, which is actually, this has happened with people too. You're like, wait, no, don't do that thing. Which was the last thing? So, yeah. What I think I would do, like at this point, you already have like the queries you put in. I would just say like, I'm going to start a new context. And then it's like, we did the Docker. It's like sometimes you have to like restart your Docker.
Gotta power wash it.
Gotta power wash it. Okay, so let's go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The great search brought to you by DigiKey, native for every single week. Ladyada uses the power of engineering to help you, yes, you find the things that you need online on digikey.com. Thank you, DigiKey, for making this segment possible. Ladyada, what's the great search of the week this week?
Okay, this subject this week is finding replacement capacitors, because I actually saw a really great thread. It's an older thread, but it was tweeted by DigiKey on how to find replacement electrolytic capacitors. So first up, let me show you what we mean, because there's a lot of different capacitors. And by doing that, let's grab this handy dandy Apple II disk drive. So if you go to the overhead, focus in. Okay, so oftentimes when you're dealing, there's people who want to repair or rework old designs. And, it's easy to get, you can actually get electronics that it's like, 30, 40 years old at this point, stuff that was made in the 80s. There's even stuff that was made in the 70s. Boy, that's stuff that's like 40 plus years old. And you want to repair it and it doesn't work. And you're like, well, what can possibly go wrong? Like when you have solid state devices, which this is thankfully, there's some stuff that's going to be damageable and some that kind of won't. So chips like this ULN, this can be blown out, like if it got damaged or from static electricity. But like the resistors don't really go bad. Resistors are resistors. They sort of last forever unless there's a mechanical strain. There's also ceramic capacitors here. These little yellow blobby ones, those are ceramic capacitors. These big yellow discs are also ceramic capacitors. Those also tend not to go bad. These red blobby ones, those are film polymer, pretty sure. They do sometimes go bad, but not super often. They're fairly more durable. Tantalums definitely dry out, and electrolytics absolutely fail. And it's very common to see people talking about like recapping a motherboard or an arcade cabinet because the electrolytic capacitors dry out, or the electrolyte inside, there's this liquid, it can flow out and it can also corrode the board around it. And so thankfully it's very easy to find replacements. I think this is a tantalum actually. You can see the plus. This might be a tantalum capacitor. Kind of hard to see. It's fairly easy to replace electrolytic capacitors, and DigiKey has them in like every stock shape and size. And so this thread, so let's go to the computer, is actually kind of neat. And it looks like they're still kind of up to, they have two threads. There is this one, which is like a massive thread. Sorry, there's this one is a tutorial thread. And he goes through, you look on the capacitor and it says, especially big ones, it says 50V, 1 microfarad. It's like, man, that's so great. You know exactly what you're looking for. 1 microfarad, 50 volt capacitor. And he has some tips and tricks, temperature rating, whether you do temperature rating, and then the sizing, you can of course measure it. He says this one is a little bit more challenging because it's when you have surface mount, you don't have markings on the side. You have usually only markings on the top. And the markings are not as obvious as these large through-hole ones where they say, like, they literally print out all the details. So for this one, you want to look at, there's almost always going to be 3 lines. The top line is the capacitance. The second line is the voltage rating, which is confusing because it's a letter. And then sometimes it's like a temperature or model, HB. And then the third one is a lot code. Again, this isn't like 100%, but it's like almost every single time it's going to be these 3 numbers. And one thing that's a little confusing is if you have large capacitance, this can be, let's say you have like a 2,200 microfarad capacitor, 2,200, 2200. This would be 222, because it would be 22 plus 2 zeros, right? Let's take a resistor code where you have 2 digits of like like numeric data, and then last digit is a number of zeros to put afterwards. But 220 isn't 2200, it's actually 220. So 220 and 221 are actually the same number, 220 microfarads. So it's a little counterintuitive. If it's 22 only, that's 22 microfarad. And then if it's 2.2 or like, 2U2 or whatever, it's 2.2. So it's a little bit different than resistors. And then here's what I didn't realize. So first off, the series code, you can search on DigiKey by series code. And so in this case, HB will tell you, and, that'll give you a, like hours rating and maybe like the physical size. But what I didn't realize is that letter underneath the number is the rating, and the rating codes are like, it's done by letter and it's consistent across. And then I started looking at all my capacitors, like, oh my God, you're right, it's consistent. J for 6.3, 10 for A for 10 volts, C for 16 volts, E for 25, V for 35, and H for 50. So when you're looking at a capacitor, you can use those numbers to, quickly figure out what it is, and then use the DigiKey search to locate a capacitor with the same physical size and microfarad capacitance and the voltage, which are the 3 things that are most important. And then what's neat is that there is like a lot of people posting, and you can like check out these threads, and like you can, like, I kind of think it would be like a good quiz time thing. It's like, okay, quick, can you find me this component replacement? So this one, their question, like, is this a 33 microfarad or 330? And it's 330, despite this 0 is confusing. And it's 6 volt. They don't have the J, instead they just say 6V, which is, fine. And then, somebody replied and said, hey, here's what I think it is. This one is pretty easy. It's a 100 microfarad, 160 volts. And then even says on the side, 85 degrees C. There are ones that are higher temperature rating. And then this other thread is like chock full of people who are like, I have to replace this. So this is 100. So 100 microfarad. And then VHA. And then remember, the first letter is going to be the voltage rating. So if you go up to here, this handy guide, 35 volts, because it's got a V. HA is the family, so you can search by HA, and then 1H3 is the lot code. And you can see this, they're actually people helping each other. This 47 microfarad, 50 volts. 47 microfarad, but then it's like, what is this U? I don't know if they have the U. This might not be clear. That's what they said. Oh, UD. Oh, sorry, the C is afterwards. So the C, this is the 47 microfarads, and it's not, UD is the lot code. C here is 16 volts. So you have to kind of like know where to look. Let's see. And then more people posting all sorts of capacitors. Check this out. Okay. And then this one is sneaky. Apparently this one is normally 47, 470, but turns out it's 47. And then this O is a little smaller. It's a 47 microfarad and 60 volt. Okay. So some examples. So check out that thread. So I thought we would do one live by looking at this one on my desk. So let's go to the overhead and we'll pick it out. Okay. So I happen to know what this is because I placed this component, but I figured it's good practice. So 220, 220 microfarads. And then you see that J. And then by looking at the table that I showed you from that DigiKey tech thread, 6.3 volts. Then you take your calipers and you measure the diameter, 6.5 volts. And then you measure the depth. It's like a little bit, it's a little tough to, hold on. Depth, 6 millimeters. So 6.5 millimeters by 6 millimeters. So then let's go to DigiKey, can go to the computer. And we'll look for 22 microfarads, 6.3 volts. You know, it's funny, it would be cool if I could use like ChatGPT to search this.
So there's some web tools that you could point it at certain websites.
Yeah.
And I think there's a debate about the robots.txt.
Yeah.
If some of these tools can, scrape them or whatever. Bard, I think you could point certain things. And what I think is going to happen is maybe even after this video, someone's going to use one of these tools to show you how to navigate a site like DigiKey. And there'll probably be some helpful things. Or DigiKey, who they're pretty sharp. I think they did the like DigiKey Alexa thing where you can ask Alexa for certain things with DigiKey. They might be working on that now. To be straight up with everyone out there, we're working on looking at our own data and only our own data and having it answer questions about like things in our Learn Guide.
Yeah.
It'll be like a big,
It's iffy. It's tough.
thing
It's
that
tough.
we're probably not going to use. But
Yeah.
the idea of being on the cutting edge with technology and microcontrollers and all this stuff is we try a lot of stuff and some stuff we won't use. But it's kind of up to us to be on the forefront of some of these tools. So if anyone is using any of these current tools like ChatGPT with any of the plugins or Bard, which can browse the web, let us know how you're using it with something like DigiKey, and maybe we'll put it in Desk of Ladyada.
Okay.
Back to you.
All right, thank you. So I searched for 220 microfarad, 6.3, and it's like, yes, you obviously want electrolytic capacitor. I could have typed in electrolytic, but it anytime you're looking for a voltage, if you just put a capacitance and a voltage, it's looking like, yeah, that's not a ceramic. Let's look for active. And your question is it polar or bipolar? And then if you go to the overhead real fast, if you have this black marking, that's the polarization mark. That's the negative. And so if you see that black mark or a negative sign on the side, hold on, I'll show on this board. You see that there's a negative arrow and it's like a little negative sign. And then here also, there's a little negative. So that means it's polar. Okay, so let's go back to the computer. So I'm going to select polar and also dash in case that includes it. And I'm going to look for a surface mount. Although if I'm looking for replacements for that disk 2, I'll be looking for an axial through hole. Let's also look for only ones in stock. And then we want to pick one that's the same size. And so diameter, remember, was 6.3, and then the height was around 6, I'm going to say, hey, maybe it's okay if it's a little bit higher. But of course, depending on what we're replacing, just make sure, like, you have clearance. But it's always okay to pick a taller one as long as it fits in that footprint. Next question, lifetime temp and operating temperature. This is, totally dependent on the functionality of the product. Most are, 1,000 hours at 105 degrees C. You can get 2,000. Some medical devices or some devices that have extreme temperatures want a little bit better lifetime rating. Of course, it isn't like total runtime. That's just like at extremely high temperatures. And then operating temperature, I'm not going to ignore this because it doesn't matter. And they have some, use cases. Ripple currents, this is all related to the ESR, the internal impedance. The lower the impedance, the more you're going to pay. For basic power supplies, usually don't really have to worry too much. Usually can go with the cheapest, but it depends. If the power supply for your device really does need to have a good quality, low ESR, pay more. On the flip side, if you're fixing up these old retro tech things, a lot of them were not made with, like, they didn't have the highest quality components at the time. Like, we get stuff for so much cheaper these days because it's so much like easier to manufacture that I think even the most basic electrolytic capacitor is going to be fine for replacing just about any motherboard or arcade or game. Okay, so let's hold on. Oh yeah, so I applied that. And then, I'll just for fun, I'll just say cut tape because I only need a few to replace it. So I'll just make sure that I can buy them in a small strip. And then there are a few families. So if you look at on the overhead again, sorry, I'm going to hop back and forth as I do this replacement. This one does have a family code on it, FN. Sometimes you're not going to, it's not like happens, I believe this is the Panasonic. Or Chemicon or Nichion, but sometimes you're using these you're replacing a generic company. The capacitor the family may not exist because the company doesn't exist anymore. But in this case, it does. So can you go back to the computer and we'll select FN? Although again, it's not really essential to do so. And then, boom, this is it. And this does look familiar. The Panasonic FN 00JO. That's the data sheet, sorry. Yep, that looks right. 220 FN, that's the code. Yeah, that's, they will even give you the marking so you can make sure the series and the code and the capacitance is identified correctly. And they're in stock. So if I have to replace a device that had that electrolytic capacitor, this would be the link I could use.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Thanks for joining us. This was a longer
I know, this was long.
waiting,
It's kind of fun.
but it was super fun because we're showing our work real time. It'll be fun to look back at this years from now and be like, look how we were slowly and interestingly interacting with this maybe new form intelligence. Or we all decide, hey, we're going to kick it Dune style and just develop our minds to fold space. You don't know.
That's right. Valerian Jihad. It's happening here at Adafruit.
Someone on TikTok said a really nice thing. It was a comment. It says, I don't know what you're saying, Electric Witch, but I really like I really like it.
I like your style. Okay.
Yeah, I like it. I like the thing that you're making.
Okay.
Which I thought was pretty cute because that's a nice thing to say. All right, we'll see everybody throughout the week. Thank you so much for joining us. That is Desk of Ladyada.
Bye, everybody.